Here's 2013 question 3. It's a Riemann sum table problem. Let's jump straight into it. Part A, they're asking us to approximate a derivative or approximating a rate, or in this case, approximating an instantaneous rate of change, our IROC here, okay? Now, if we had the function, we could just plug and chug it out there, but we're not given a function, so we have to do the next best thing, which is to find an average rate of change as close as possible to 3.5. So in this case, 3.5 is right in between 3 and 4, so we're going to use these 2 points here. It's a simple plug and chug. I'll direct you to the scoring guidelines here. It's pretty much 12.8 minus 11.2 all over 4 minus 3. You could leave it like that. Equal is equal. You could even reverse the top and the bottom and still get the same answer. This is a calculator question, so you could crank it out if you wanted to, but still, you really don't have to here, okay? The second part of part A, they tell you to indicate the units of measure, okay? So, very easy point to earn. 12.8 and 11.2, if you look at the table, were measurements of ounces. And 4 and 3 were measurements of minutes. So this is basically ounces per minute. Okay, and that's it. There's 2 easy points right there. Part B, here we go. Part B, is there a time where a derivative comes out to 2? Okay, from 2 to 4. So they actually point you in the right direction. You're only looking from 2 to 4 here. So they're asking you, is it possible for this to happen? Okay, so right away, the phrasing of this question, I'm either thinking IVT or MVT. But because they're talking about a derivative, right away, I'm going to think of MVT here. So what I'm going to do is, MVT is pretty much the conclusion of it is where the average rate of change is equal to the instantaneous rate of change, or where the secant line is parallel to the tangent line here, okay? So pretty much what they're telling me to do is it possible for an average rate of change to come out to 2? So we're only looking from 2 to 4, okay? So from 2 to 4, I noticed that if I subtract 12.8 and 8.8, I actually get 4. And if I subtract 4 and 2, I get 2. So the average rate of change here is basically 4 divided by 2, which comes out to 2. Okay? So the average rate of change, let me illustrate this for you guys. You have a curve. Right now, the average rate of change between these 2 points is a slope of 2. So the mean value theorem will guarantee that there's a tangent line that's also 2. But MVT, remember, only works if you know if 2 conditions are met. The function has to be continuous and differentiable from these 2 values here, okay? Specifically, continuous on a closed interval and differentiable on an open interval. So do they give us any clues? They do. You got to read it a little bit, but notice how they tell you that the function is differentiable, okay? If a function is differentiable, then it is also continuous here, okay? So MVT does apply, so you know it can work. So notice how they mentioned that C is differentiable, implying that C is continuous. But also, they showed that the average rate of change came out to 2. So then you just make your conclusion. By MVT, there's at least one time where that's going to happen. Okay? Those problems take a little bit of practice. It's not too straightforward as part A, but still very doable with time. Okay, so just keep that in mind. Part C, we have a midpoint sum and we're approximating an average. Notice how we have that 1/6 right there. So just keep that in mind there. Midpoint, people tend to get thrown off based on the number of intervals that they would want to use. But here they actually tell you that you want to use 3 subintervals. So let me make some space here on my table. So notice how that they want us to go from 0 all the way to 6, but they only want us to use 3 subintervals. So I'll explain this two ways. The first way, you're drawing 3 rectangles from 0 to 6. So the only way to do that is if you have a horizontal distance of 2. Okay? That's the only way I can squeeze in 3 rectangles. Now, the other rationale is some people will try to draw 6 of them. But the thing is, if we look at 0 to 1, the midpoint will determine the height. The midpoint in this case is 0.5, but the thing is, we don't know what C of t is at 0.5. Now, if we had the function, we would be able to figure that out, but we're limited in the amount of information that we have here. So look, if I actually go from 0 all the way to 2, the midpoint is right here at 1, and I will actually know what the height is. Okay? So if we take a look at these 3 rectangles, what's their width? What's the horizontal distance of each rectangle? Okay? Some people might write 1, but it's actually 2. If you notice, from 0 to 2, from 2 to 4, from 4 to 6, that is a horizontal distance of 2. So that's going to be 2 times the first rectangle. The height is going to be determined by that midpoint, 5.3, plus the next rectangle is going to be 2 times 11.2, and so forth. 2 times 13.8. Okay? So they wrote it here. They wrote 2 times C of 1, C of 3, and C of 5. You guys are more than welcome to do that, but it's really not necessary here, okay? Don't forget that 1/6. That would be the first thing that I would do here. I personally would not write this first portion out, because if you don't write it with the approximation symbol, you could actually lose your point. So in this case, less is better. Less is more. I would encourage you to just leave it right there. Equal is equal. You would right away earn your first and your second point. Now, in part C, they also ask you to interpret the meaning using correct units. So what did we just find? Okay, that 1/6 should tell you that we found the average. Now the average what? What the heck is C, right? C of t is just measuring the amount of coffee in the cup. So if we put those two together, this is going to be the average amount of coffee in the cup. Now, how do we measure that? They measure it in ounces. And this is the average amount from when to when. They mentioned that it's from 0 to 6. 0 to 6 what? In this case, it's minutes. So that'll earn you your third point. Very doable. Definitely more straightforward than part B. So try to earn your points there, okay? Last one. The amount of coffee in the cup is modeled by B of t. So they introduced this new function B of t that represents the amount of coffee in the cup. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Okay? Rate just means exactly derivative. So you're really just finding b prime of 5. Okay? A quick plug and chug here. B prime of 5. Is this a calculator question? It is. Okay, so I would program y1 as b of t. And then I would go to my home screen and I would go to math 8, d over dx of y1, and evaluate it at x equals 5. And that's it. You should get your answer. Here they kind of just wrote it out. I don't think they asked for units. They didn't. Now, some people asked, we actually did this in a quiz, I believe. Some people ask you, well, why would they work out b prime of t if it's a calculator question? Okay? So, great question. The reason why is sometimes people run out of time in the calculator portion. But the moment you guys do numbers 4, 5, and 6 on the AP exam, you're actually allowed to go back to numbers 1, 2, and 3, but just without a calculator. It's kind of like how I set up all of my tests with you guys. After you finish your blue exam, you can go to the yellow exam. But you could always go back to the blue exam without the calculator. So they give you partial credit here in the case that you ran out of time and you can only go back and do it by hand. So this is the reason why they have the scoring guidelines like this. But you can basically plug and chug and you get your answer there. Okay.